Hello, Course 3 students, and welcome to our third lesson of Unit 1. In this lesson, our objective is I can apply properties of numbers and find counterexamples. So what we're going to do in our agenda for today in this video is to review your properties, number properties. We have two examples of determining properties as well as solving them. And then you have one example on that counter example. So here are my different properties, and I want to take a look at these as we go through. So you have your commutative property. Here it is out in number. So for the most part, they didn't give you like the actual textbook definition. They give you that kind of number format to help you describe it, but also it's a way you can see it here in your algebra form too. But what it means is that you can add things, and it does not matter the order. When you add them, you will still get the same solution, okay, if you're adding as well as if you're multiplying. Doesn't matter if 12 comes first or 8 comes first when you multiply, you would still get the same answer. And the same thing works for addition. So this is a property that would work for addition as well as multiplication. Your associative property, that is the one that starts combining with your parentheses. And so in this case, it's showing again an addition problem here. So on each side of the equal sign, there's an addition problem. 7 plus 9 plus 1. The order is the same here on each side. It's just a matter of where those parentheses go. This one's around the 7 and the 9, this one's around the 9 and the 1. If you know your art of operations, you should do your parentheses first. But since they're adding all the same numbers, it's going to end up being the same solution. And the same thing works then for multiplication. So whether you group the 4 and the 2 together, or the 2 to the 5, or if you moved the 4 over and did the 4 and the 2 together, or 4 and the 5 together. This again will be a property for addition and multiplication. Your distributing property, this is probably my favorite property. And what it means is that if I've got an operation where I have a coefficient on the outside of my parentheses, I will then distribute these numbers to the inside of it. So then what it ends up being is a multiplication problem. So within the parentheses, I don't use the order of operations to do the parentheses first. This is one of the rules to the exception where I would want to distribute. So I would distribute the 6 to the 9, so I'd have 6 times 9. The operation of addition still stays in the middle, and then I'd have 6 times 3. The last two are a little bit simpler ones because they're talking about your identity property and your zero property. So your identity property means that the identity of that number is going to stay intact or stay together. So 7 is 7, so what could make 7 still be 7? Well, adding a 0. Okay, 8. And what would still give you 8? 1. So if you're using multiplication, you are multiplying it by 1 to keep that identity the same. If you're doing addition, you just add a 0 to keep that identity. And then your last one that we're talking about is your zero property. So that is just remembering that anything multiplied by 0 is going to give you a solution of 0. To be honest, the harder ones to remember are probably these top two. So we are going to go ahead and take a look at some of these properties within some equations and determine if they are equal to each other. So we're going to get an equation where it has like something on the one side of the equation, one on the right side of the equation, and we have to decide, are they similar by using those properties, or sorry, are they equivalent, not similar? So one thing I want to suggest though is if you would like to write these down, this would be a really good stop to pause and to take a look at that if you need to. Alrighty, so let's go ahead. I'm going to move myself around here. So this one says, example 1, identify equivalent expressions. Use properties, so we're just using the properties, we're not actually determining what property, to determine whether the expressions are equivalent. So I need to decide if 3 times y times 5 and 15y are equivalent. Now, if I look back at my properties, this, since it's an entire multiplication equation, I would say is my associative property, okay? So within my associative property, I can multiply things together no matter what order I want to do. So in this case, it just has a 15y. So what I want to do is I want to look at these constants or these coefficients, really they're coefficients, and multiply them together because they're all being multiplied. So 3 times 5, yes, that does give me 15. I'd still have the y, and yes, 15y equals 15y. So really my question was, use the property to determine whether the equivalents are equivalent. So I would say yes, equivalent. All right, so those two are equivalent. Now let's look at B. B looks like I've got a distributing property, and the other one looks to be fine from where I'm comparing them. So I've got this one that looks to be completely fine. It's as simplified as I can get it. So we're going to simplify this one by using our distributing property. So it has a coefficient of 4 here. I've got a variable of x, and I've got a constant of 7. I have to make this 4 go to each part within the parentheses because I don't know what x plus 7 is, do you? You can't do the operation in the middle here without distributing it. So we're going to distribute 4 to the x. So 4 times x is 4x. The operation in the middle still stays as a plus, and then I'm taking that 4 to the 7. 4 times 7, which is 28. So we're comparing 4x plus 28 to 4x plus 11. Well, they both have a 4x, but their constant is not the same. 11 and 28, not the same. So this would be no, not equivalent. They are not the same equation or expression. So let's go ahead and look at 2 then. Problem number 2 here is talking about consumer math application. So this is about, what could the consumer do? So it says Sasha's list of favorite movies include 12 action films, 19 comedies, and 8 science fiction science fiction films or sci-fi films. Use properties and mental math to answer each question. How many movies are on Sasha's list? All right, well, let's think about this. Let's use our power math. We will underline our problem, use properties and mental math to answer each question. Here's my question. How many movies are on Sasha's list? Your operation would be important to circle. I'd almost say some of your clue words for that is probably the list, because the list is a number list. You'd add things from a list to count them up. All right, and then it would be important to know that I have 12 action films, 19 comedies, and 8 science. So if I'm using my properties, doesn't matter how I add them, but I'm going to use the commutative property to add them together. So 12 plus 8, okay, if I wanted to write it out I can, but 12 plus 8 gives me 30, plus 19, which gives me 49. So there are 49 movies on her list. So let's see what B asks then. Oh, I did that wrong, guys. It's 39, because 12 plus 8 is 20, not 30. You'll have to correct me if I make mistakes. Sometimes I just move too fast in my own videos. I feel like I do better when it's in person than it does on a video. Get a little stage fright here on the video. Let's just make sure we got that. 12, 8, and 19. Okay, good. All right, so B then. It costs $8 to download a movie. How much money would Sasha need to save to download all the movies on her list? Well, again, here's my question. How much money would she have to save? The important part, I would say, your clue word probably is going to be in this phrase here, but the $8. This is going to turn into being a multiplication problem. So one way we could do this is we could already go in and be like, okay, well, we added 12 plus 8 plus 19. We can make this a distributing by adding an 8. So in this case, since I have no variables, one other way you can solve it is just by solving the inside, like we've done already, which is 39. And then we can actually solve it by multiplying it out. So I'm going to grab a calculator here. I'm just going to use my phone today. 8 times 39. So it looks like it is going to cost her, that's a lot of money. If she wanted to rent all these movies, and maybe it's like a rent to own, since, you know, everyone has like Netflix and Hulu and stuff now, or maybe it's a download, you know, and you own it for the rest of the time, forever. It's going to cost her $312 to have all those movies on hand. It's pretty expensive. But if you added little by little, it wouldn't be too bad. All right, so we're going to start talking about then your counter examples. So let's take a look at this part. It says a conjecture is a statement that is believed to be true. A conjecture is based on information reasoning and may be true or false. A counterexample is an example that disproves a conjecture or shows that it is false. One counterexample is enough to disprove a conjecture. So it's kind of like in science where you come up with a theory. If the theory could be true, it may not be true. A hypothesis is more so what I'm thinking. Your hypothesis could be true or could not be true. And then your counterexample could be your evidence. Okay, so this is kind of the math term of it. So again, I say your conjecture is a lot like a hypothesis. It's a statement that, because it's believed to be true. I would say this is more of a theory. So theory is like a statement that is believed to be true until someone else proves it otherwise. So your counterexample could be proving against the theory that the theory is wrong. So let's look at this. It says, using counterexamples, find your counterexample to disprove the conjecture that the associative property is true for division. All right, so we got to go back and let's look at what our associated property is. I always get confused on my properties too. Okay, so it's this one where, you know, you're multiplying all the way through and you're just changing up your parentheses. So let's come up with an equation where we have 3 different things that we're dividing. Let's go like this. Okay, let's have 100, because I know 100 is easy to divide. Divide it by 10. And then 100 divided by 10 is 10, and then let's divide it by 2. I think that'd be easy. So on each side, let's do that. All right, and then the problem is that we need to make sure that we add in some parentheses, because the associative property has parentheses. So on the left side, let's get 10 and 100 together. I just came up with a random problem on my own. I'm pulling these numbers just kind of out of my head because I know that I could easily multiply this if it was in order of operations, because 100 divided by 10 is 10, then 10 divided by 2 would be 5. So let's add our parentheses here, and then we'll do this one too. So now, because I added parentheses, it changes my order of operations. So when I originally did this, and I just had 100 divided by 10 divided by 2, my solution was 5, because you go left from right, so 100 divided by 10 is 10, 10 divided by 2 is 5. In this case now, I actually have to follow my order of operations, which means I need to do my parentheses first. So 100 divided by 10, that is still 10, so then I do 10 divided by 2, that is 5. So this is on this side of my equation, I get a 5. All right, and how about on this side? So now we have to actually do the 10 divided by 2. 10 divided by 2 first is 5, and then 100 divided by 5 would actually be 20. So as you can see now, we have given a counterexample to this. They said that the phrase or the conjecture was that the associative property is true for division, and we just proved that it is not. Because does 5 equal 20? No, 5 does not equal 20. So here is my math and here's my proof. I will see you guys in the next lesson. Let me know if you've got any questions.